welcome to the next section. For the chapter 5, you can see the previous video, or I also have put the Microsoft Excel file with the name chapter 5. If you want to review it again, you can just download it. For the chapter 6, we will review about the evaluating flexibility and the NPV, or net present value. I also have put the Microsoft Excel file with the name chapter 6, so it is recommended that you download the Microsoft file. So this is the example from the book that Pariski also have explained before in the class. So there is a solar company where they primarily sell in Europe. So the solar company have a demand for 100,000 panels per year, and the price is 70 euro per panel. And they face the situation where their annual demand may increase by 20%, and the probability of this increase is 0.8, or they can face the decrease of the annual demand by 20%, and the probability is 0.2. And they have to decide where they will build a plant. Is it in Europe or in China? So we also have the information here where the plant with a rated capacity of 120,000 panels, and the current exchange rate now is 9 yuan per euro, and the exchange rate also expected to rise by 10%, and the probability of this rise is 0.7, or they can drop by 10%, and the probability is 0.3. And they have a sourcing decision over the next 3 years, and the information is the discount rate, or the K, is 0.1. And this is the table of the fixed cost and variable cost in each plant. So in European plant, the fixed cost is 1 million per year, and the variable cost is 40 euro per panel. And European have the range production of 60,000 to 150,000 panels. And China's plant, they have a fixed cost for 8 million yuan per year, and the variable cost is 340 yuan per panel. And the China's plant range production is from 100,000 to 130,000 panels, and they will incur variable cost for 100,000 panels, and they will lose sales if the demand increase is above 130,000 panels. So from this, we can see that the European seems like more expensive, but it has greater flexibility. So the DSR company needs to decide where their plant will be built. The first step is we need to evaluate the options using expected demand and exchange rate. Actually, it is not a must step. It is just for comparing with the decision tree later. So first, we need to compute the average. The average demand expected to increase is by here 20% times 1.8 minus 20% times 1.2. This is the probability of their demand will increase, and this is the probability of their demand will decrease. And the increase is 20% and the decrease is 20%. So we get 12%. And this is also the yuan expected to strength, where the probability they will rise 10% is 1.7, and the probability there will drop 10% is 1.3, and we can just like before multiply and then minus, and we got 4%. And then the next step is we need to compute the expected future demand and exchange rate. So it said that we need to decide for the next 3 years. So the next 3 years is the current year, which is the period 1, and the period 0, and the next year is the period 1, and the next 2 years is the period 2. So there is 3 years, the current years now, the next year, and the next 2 years. So for the period 1, the demand is 100,000 plus 100,000 times 12%. So 100,000 is the current demand now plus the average demand expected to increase. So we get 112,000 panels, and for the exchange rate, the current exchange rate now is 9 yuan per euro, so it is just 9 minus 9 times 4%. It is minus because it is expected to strengthen because 1 euro equals to 9 yuan, and it will become strengthen with 1 euro equals to number lower than 9. So it is 9 minus 9 times 4%, and we get 8.64 yuan per euro. And for the period 2, also the same, the computation. The demand is just the demand in period 1 here, 112,000 panels plus the demand before times the average demand expected to increase 12%, and we got this number. And then for the exchange rate, also the same like before. Just input the exchange rate in the previous period, 8.64 minus 864 times 4%, and we got this number 8.2944 yuan per euro. And then we need to evaluate the discounted cash flow or DCF for the onshoring Europe and for the offshoring in China. So first, for the onshoring in the Europe, for the period 0 profit or the current year now, it is just the revenue minus the total cost. So the revenue is the demand 100,000 times 70, the price, minus the 1 million euro, the fixed cost, minus the 100,000 demand times the 40, the variable cost, and we got 2 million euro. And for the period 1 profit, also the same, revenue minus the total cost, but the change is in here, the demand, where the period 1 is using the demand here, the 112,000, and we get the profit here, 2,360,000 euro. And for the period 2 profit, also the same, the change one is the unit demand. We use the unit demand here in the period 2, and we get this number. And then for the expected profit or EP from onshoring, it is from this formula. So the current profit plus the next period profit divided by 1 plus k squared by 1, and then plus the profit in period 2 divided by 1 plus k squared by 2. So just input the number, so 2 million euro plus 2,360,000 euro divided by 1 plus 0.1 squared by 1 plus the 2,763 and 200 euro divided by 1 plus 0.1 squared by 2. And we got this number for the expected profit from onshoring is 6,421,091 euro. And then for the offshoring in China, we also compute like before the period 1 profit until the period 2 profit. The difference is we need to divide the cost by the exchange rate in the each period. So from here, the revenue is 100,000 times 70, the price in euro, minus the 8 million divided by 9, the exchange rate in period 0, minus the 100,000, the demand in period 1 times the 340 divided by 9, the exchange rate in period 0, and we get this number. And then for the period 1 profit, also the same, the difference is the unit demand and the exchange rate. So the unit demand is 112,000 and the exchange rate for the period 1 is 8.64. Just compute it and we got this number. For the period 2 also the same. The difference is the unit demand and the exchange rate for the period 2. And we get this number. So for the expected profit, we also compute with the same formula as before. So the period 1 profit plus the period 1 profit divided by 1 plus 0.1 squared by 1 plus the period 2 profit divided by 1 plus 0.1 divided squared by 2, and we get this number. So if that's the simple DCF here, the seller should pick offshoring because it has bigger NPV, but there is an uncertainty, so we need to calculate with the decision tree. So this is for the decision tree. The first step is to draw the nodes of the decision tree. So there are 3 years, which are period 0, the current year, and then the next year, the period 1, and the next 2 years, the period 2. So first, for the period 1, there is only one node because that's our current situation where the demand is 100 and the exchange rate is 9. And for the period 1, there is 4 nodes here because there is the probability where the demand is increased and the exchange rate also increase, and the demand increase, exchange rate decrease, and the demand rate decrease and the exchange rate increase, the demand rate decrease and the exchange rate decrease. So there are 4 conditions. And then for the period 2, there is 9 nodes. Or you also can draw 16 first and eliminate the one that intersect or have the same node. And this is the result later. So for each node in period 1 here, there are also 4 possibilities as you can see here. So each one have 4 conditions, and thus in the period 2 we get this number of nodes. After we draw the decision tree, the next step is we evaluate for both of the options, but first we just evaluate the onshore option, which is the European plan, which has production range from 60,000 to 150,000 units. We evaluated from the further period, which is the period 2. So for the period 2, these are the nodes, and then we just move the nodes here where D is demand and E is the exchange rate. So we made this table, and then for the revenue later, it is get from the price times the demand unit, and for the cost, it is fixed cost plus variable cost times the demand, and for the profit, it is from revenue minus the cost. So for example, for the nodes that is the demand is 144,000 and the exchange rate is 8.91. The revenue is the 144,000 units, the demand times the price 70, and we got this number, the revenue. And for the cost, it is just the fixed cost in Europe, which is 1 million euro plus the variable cost in Europe that is 40 times the demand here. And we got this number. And for the profit, we just compute it from the revenue minus the cost, and so on. For the detail, you also can see it from the Microsoft Excel file. And then for the period 1 evaluation for the onshore option or the European plan. So the period 1 is here, the notes, and we made this table that contains expected profit or EP from EP period 2 that will be discounted to period 1, and also the PVEP or present value of expected profit from period 2 that will be discounted to period 1, and then the revenue, the cost, and the expected profit of the period 1 or the profit for this period that we will get from the revenue minus cost plus the PVEP here. And then for the EP, period 2 that discounted to period 1, we get it from the multiplication of each probability times the each profit period 2 that is we get from the previous slide. So 0.24 is we get it from here, the note here, the 0.8 times the 0.3 times the profit in here, which is the 3,320,000 euro, plus the note here 0.8 times the 0.7, which is 0.56 times the profit in this note, that is 3,320,000 euro, and so on, and we got this number. So for this column, it is the same. And then for the PVEP, the formula is the EP in this previous column divided by 1 plus 0.1 squared by 1. So for example, in this notes, the PVEP is 3,032,000 euro divided by 1 plus 0.1 squared by 1, and we got this number. And for the revenue, it is still the same, the demand here times the price. So 120,000 units times the 70, and we get this number. And then the cost, it is also the same, the fixed cost plus the variable cost times the demand here, and we get this cost. And for the expected profit in this period, or the profit, we just calculate it from revenue minus the cost plus the PVAP. And as you can see the detail from the Microsoft Excel. Then lastly, for the evaluation for the onshore option, which is the period 0 evaluation. So the decision tree is here, and the table is this. It is only one row because in the period 0 there is only one node. With the demand only 100,000 and the exchange rate is 9. So for the EP, or expected profit in period 1, that will be discounted to period 0, the formula is the same as before, which is the each probability times each profit period 1 that we got from the previous table or previous slide. So this probability times the profit here, this probability times the profit here, and so on. And for the PVEP period 1 that will discounted to period 0, also the same, the formula EP period 1 in the cell divided by 1 plus 0.1 squared by 1, and we got this number. And for the revenue, it is also the same, the demand units here times the price, which is 100,000 times the 70 euro, and we get this number. And for the cost, also the same, fixed cost plus the variable cost times the demand here. And for the expected profit in period 0 is same, revenue minus the cost plus the PVEP. And we got the expected profit in period 0 is this number. And then the next step is we evaluate the offshore option that is from Chinese, with the production range from 100,000 units to 130,000 units. And in this plans, there is a condition where if the demand is increased above the 130,000 units, they only can sell 130,000 because that is the maximum range of production from the Chinese plants. And if the demand is below the 100,000 units, the variable cost will be still 100,000 because that is the minimum range of their production. So the step is also the same like before. We evaluate from the foremost period, that is period 2 evaluation. There is the nodes, the revenue, the cost, the profit, and this is for the picture of the decision tree in period 2. And then for the example, we need to be careful with the computation in here. So for example, in this blue box, the revenue is 9,100,000 euro because we get this from the 130,000 multiplied by 70. Even though the demand is 144,000 units, we only can sell 130,000 because that is our maximum range in the Chinese plan. So the revenue is this. So we do not multiply 70 and the demand here, but we multiply it with the maximum range of production. And another example is in this purple box. the demand here is 96,000 units. And yes, we can fulfill that with our production range. So the revenue is 96,000 times the price 70, and we got this number. And then for the cost, the cost in these notes is the fixed cost in the Chinese plants, which is 8 million yuan plus 340 yuan times the amount that we purchase, which is 130,000. That is the maximum range, and then we got this number. And for this note, the yellow box, also the same, the fixed cost plus the 340 times 100,000. Why it is 100,000 units? Because even though the demand is 96,000, but our minimum range of production is 100,000 units. So we calculated with the minimum range, and we got this number. And then for the profit, keep in mind that these costs are in the yuan currency, and we wanted to change it to the euro. So it is the revenue minus the cost divided by the exchange rate. And for this note, for example, we get the revenue minus the cost divided by the exchange rate in here, and so on. Next is the period 1 evaluation. It is also quite the same with the onshore option previously. So these are the table, and this is the decision tree of period 1. So the column is also the same for the EP period 2 that will be discounted to this period, the period 1. The formula is the each probability here times the each profit from the previous period that we get from the previous table, and we got this number. And for the PVEP in the period 2 that will be discounted to this period, we got this number from the EP period 2 in this column, divided by 1 plus 0.1 squared by 1, and then we got this number. And then for the revenue, it is just the demand here times the price, but please pay attention that it needs to be in our range of production. So if the 2 row here, it is okay, and we can fulfill it by our range of production. And for the 2 last row here, for the 80,000 units, we also can fulfill it, and we can also just multiply the 80,000 units with 70 euro. But the cost, it will be a little different, because we need to pay attention with the minimum range of our production. So the yellow box here, the cost we get from the fixed cost plus the variable cost times 100,000 units, because that is our minimum range of production. And we get this cost in yuan, and for the expected profit in period 1, we get this from the revenue minus cost divided by the exchange rate plus the PVEP, and we got this number, the expected profit period 1 in euro. And lastly, for the period zero evaluation in offshore option in Chinese, also like this, the table and the division tree, the row is only one with the notes 100 and the exchange rate is 9. And for the EP period 1 that will be discounted to period 0, the formula is also the same. It is each probability times the each profit from the previous table in the period 1. So the probability here times the profit in this notes, and we got this number. And for the PVEP period 1 also the same, just this number here divided by 1 plus 0.1 squared by 1. And for the revenue, it is also only the demand here 100,000, which is in range of our production range, and we got 7 million euro. And for the cost, it is also the same, just fixed cost plus variable cost times the demand here. And for the expected profit in period 0, we got this number from revenue plus cost here divided by exchange rate, which is 9, plus the PVEP in here. So for the conclusion, we got the expected profit in the period 0 for the onshore and offshore. So based on this calculation, the solar is better to onshore or build their plant in Europe because it has higher expected profit than the offshore option. To see more in details, you also can download the Microsoft Excel file that I have attached in the Google Classroom. For each cells in the Microsoft Excel for the chapter 6, there is a formula, so I hope that you won't be too confused. You can check it one by one if you want. Okay, that's it for today. Thank you for watching the video and for read the materials. Please have further reading on Chopla's book. If you have any question, you can ask me through personal chat or group chat. Thank you.